Well, since my last video, I've tried to change how I travel to avoid us using two cars. I've combined cycling with public transport and used a larger backpack for shopping and recycling trips, on the bike that is. And over the last couple of weeks we have never needed to use two cars simultaneously. What then should we do about the remaining car in the future? It's coming up to 5 years old in the autumn and has done about 27,000 miles and still is in decent condition. Do we keep it or do we change it? And if we change it for an electric car, should it be a hybrid, a plug-in hybrid? What kind of EV should we use to try to reduce our carbon footprint but still work for us? Well, there are many low carbon vehicle options available now. So let's look at a selection from a spectrum of the internal combustion engine, the ICE, through to an electric vehicle. Some of this is guided by figures from the Low Carbon Vehicle Partnership, low CVP. Our own vehicles are conventional ICEs, one petrol, one diesel, and all the energy comes from burning the fuel. Petrol engines are about 30% efficient and diesel about 45%. Both intrinsically give off emissions of CO2, but also some CO, nitrogen oxides and carbon particulates, which affect climate change and air quality. These are called tank-to-wheel emissions. For comparison, a direct electrical drive vehicle is near 90% efficient, and there are no tank-to-wheel emissions, and so no exhaust catalyst train is needed either. A gentle step on the hybrid trail is called a mild hybrid. Such systems rely on the ICE to drive the wheels, but have an additional electric system, for example to capture energy while braking and using it from a battery to assist during acceleration. It is estimated by What Car to increase efficiency by about 15%, with a corresponding reduction in emissions. The next stage is a parallel hybrid in which there are two drive systems, one from the ICE and a second electric one. Such cars can be powered by the electric, the ICE, or both sources of energy. And my first experience was in a taxi near Barcelona, and it was clear it would be good for the locality to have less noise and air pollution. The increased complexity in the vehicle has resulted in an increase in the embodied carbon from that of a petrol equivalent, and the difference is about 1 tonne of CO2e, from 5.6 to 6.5. But over the lifetime of the vehicle, the reduction in emissions is estimated to be about 3 tonnes, from 24 to 21. Plug-in hybrids also have a parallel drive system, but a proportion of the energy utilised is now provided by electricity. The scale of the electrical input can provide electric-only journeys of about 20 miles or more. There is a further small increase in embodied carbon, about 200 kilograms of CO2e, resulting in a further reduction in the lifetime emissions, about 2 tonnes of CO2e. Finally, there is the electric-only EV, in which the drivetrain from the combustion engine is absent and the locally clean propulsion is provided. There is a significant increase again in the embodied carbon by about a further 2 tonnes, and that mitigates against the further reduction in lifetime emissions. For both plug-in and electric vehicles, reduction in emissions over the lifetime of the vehicle were estimated to be about 5 tonnes of CO2e. So what does this mean for the decisions that we might take? As in the previous video, published figures are based on a standard car lifetime of 15 years and 150,000 kilometres. That's 93,000 miles. That distance amounts to about 6,200 miles a year, and I think our use is about a third less than that now. So I'll split the difference and estimate on 5,000 miles as an annual usage. According to the Which Free Car CO2 checker, our current use of the car results in emissions of about 1,100 kilograms of CO2e annually. That's if we use the tank-to-wheel estimates. If instead we take the well-to-wheel estimates and so include the extra emissions for extraction, processing and transportation, that increases to about 1.3 tonnes per year. Again, using which estimates and our annual use for a plug-in hybrid equivalent, the car's emissions from tank to wheel are somewhat reduced by about 300 kilograms. And as a result, the estimate of the break-even time for emissions would be about 7 years. However, the well-to-wheel figures are very similar to a diesel version, and so the break-even would be a lengthy time period. But this will depend strongly on the fuel mix used and the source of electricity. If instead we look at a pure EV, albeit one with a slightly smaller model, the break-even estimate is about 2 years based on tank-to-wheel. The well-to-wheel estimate would be about a 7-year break-even time. However, this is very sensitive to the electricity source, and given our own green supplier has 100% renewables, this is probably an overestimate of the break-even time. So the best guess is that the break-even would be in a few years. As my mother-in-law defined few as 4, we would pass the break-even time in our likely ownership. It does therefore offer the potential of being a greener travel option. To be useful for us, the range has to be over 200 miles. Then the concern is over the extraction and transportation of strategic materials like cobalt, rare earth metals and lithium. Alternative battery materials are being rolled out, and so some of this concern has been addressed. This will also reduce the embodied carbon of EVs and so reduce the break-even time. And I'll cover that on the next video. But so far this shows us, at least, we have a direction of travel.